Hello and welcome back to Roboguide training. I'm going to demonstrate Lab 20 today, and Lab 20 makes use of a position register as an offset to points in a program. So if you look at a position register, you've got inside the position register values for X, Y, Z, yaw, pitch, and roll. Those are all Cartesian positions, and then the rotation about the Cartesian positions. When you create an offset, if you take a point in your program and add an offset to it, what it does is it adds the values that are in X, Y, Z, yaw, pitch, and roll in the position register to the values of the point, which also has the same 6 values. So what we can do is run a sequence, a motion sequence, and as we go through the motion sequence, each time we go through, it can increment in the Z direction or the X direction or the Y or in multiple directions at once. So I'm going to start off by demonstrating the mechanics of doing that. The first thing we're going to have to do is to designate a position register. I'll use 5, register 5. I'm going to call it offset. And then what we have to do is go inside the position register. So you click on this asterisk, click position, and zero it all out. You just have to type in all zeros. So we're just kind of initializing the whole register to 0. Now, in the handout for Lab 20, there's a suggested program to enter. What I suggest you do is take the square program and copy it rather than reinventing the wheel. We're going to use the square program as our basic motion, and then we're going to add the offsets to it. So we have to just take square, do a copy, and I'm going to call this offset. So I'm going to open that program, and it already has much of what we need here. It's got the user frame and tool frame, the return beginning at home and returning to home. So the first thing we're going to have to do is to insert a loop that counts 5 times. We're going to do this 5 times in the program. So I need to designate a counter register. So I'm going to go back here to registers, and let's use number 3 as our counter. So I'm going to insert a few lines. I'll just put a bunch of them in there so I have plenty of room. So whenever you're doing loop counting, the first thing you need to do in the program is to initialize the counter. So we need a register command, blank equals blank, so it's going to be register 3, which is my counter, equals 0. And then the next thing we need is a label where we're at the point where we're going to jump back to. So I'm going to jump back to, we're going to keep jumping back to this point 1. So I'm going to insert some lines there. And that's going to be my label. Next thing we need, after we're done with the motion sequence that we're going to be repeating, is an increment and then a test. So I'm going to insert a couple of lines here. So when we get done with the square shape, we're going to increment the register by 1. So that's going to be a blank equals blank plus blank form. What we're going to do to increment is register 3 equals register 3 plus 1. which is a constant. So that's just going to take whatever value it is in register 3 and increment it by 1. Then we have to do a test. It's an if select. And as long as register 3 is less than 5, we're going to keep jumping back to label 1. Okay, so this is a good time to just test the program, make sure it works. We're going to come back and add a couple more things to it. There's once through the square, twice, 3 times, 4 times, and this should be the last one. Okay, so we've got it looping. That's good. Now what we have to do is deal with the offset part. So just in the same way that we reset the counter to 0 at the beginning, what we're going to do is use the position register offset to offset the Z coordinate. And so we have to set that to 0 when we start the program. Remember, we already typed in zeros for the rest of the coordinates in that position register, so we don't have to deal with those. We're just working with the Z. So I'm going to insert a command, which is a blank equals blank command. Now, what we're doing is we're singling out a specific coordinate in a position register. So this is the form we need, PRI, J. It's position register 5, which is my offset. And if you remember, the coordinate for Z is the third one. It's X, Y, Z. Number 3 is the Z direction. And we just want to set that to a 0. So whenever we start the program, it initializes the Z to 0. Then what we have to do down in the program is every time we go through the loop, we increment that Z direction by, I'm going to use 15 millimeters. So I've got to insert another command here, a line I mean. And to do the increment, it's another register command. It's going to be blank equals blank plus blank. So here's the form, PR, position register 5, element 3, equals same thing. Now this, to get this, that same value, that same command in, we have to cursor all the way over here. For some reason they put it way down here in the menu. So cursor all the way over, get the same command, equals 5 by 3 plus a constant of 15 millimeters. Okay, so if we just did that, it wouldn't, the position register would increment, but in order to actually have it affect the points, we have to add the offset option to each one of these points. So that's the last part of this. So to do that, if you go to a given position command, motion command I should say, click to the very right-hand side of it, and there's a choice that comes up, and this is where you see this offset position register. So we're just going to enter position register 5, and we have to do that for every point that we want to offset. Whoops. Offset position register 5. Offset position register 5. 2 more of these. Okay. So that should do it. I'm just going to clean up a couple of blank lines that I don't need up here. Okay, so now we're going to just test it out and make sure it does what it's supposed to do. So I'm just going to use the cycle start. The nice thing about this is it actually traces the path, and you can see the path that it's following. So there's the second square. Third. That's number 4. And this should be the last one. Okay. So I hope you enjoyed that presentation. That is lab number 20. Good luck with your own version.